भारत is under attack.
आज हो रहा है, कल भी हुआ था और आने वाले कल में भी होगा।
अटैक मिसाइल, बम या गोलियों से नहीं हो रहा है, इंटरनेट की डार्क दुनिया से। इससे हमारे देश की सिक्योरिटी को जानलेवा खतरा है।
Talking about malicious attack, our power sector and demilitarized zone have faced many malicious attack in past few years.
So the topic of our today's video is to detect malware trojans in softwares used in power sector, and we are also going to propose a solution which can protect your systems from critical infrastructural damages.
But before moving to the solution, let's first understand what is malware trojan.
A Trojan malware is a type of malicious software that disguises itself as a legitimate program or file to deceive user into executing it. Once activated, it can provide unauthorized access to a computer system, steal sensitive data, or perform other malicious actions without the user's knowledge or consent. So now I am going to propose the working model of our solution, in which I have divided the various flow of program into some steps. So the step that comes first is registering the software with digital signature. So the first section is labeled as a blockchain solution. The flow that starts with a software registry node. This represents blockchain based registry where all the software versions are recorded along with their digital signatures. These digital signatures ensure the authenticity and integrity of the software. Now let's move to the second step, which is decentralized software update. From the software registry, the flow proceeds to decentralized software updates. This step involves a decentralized system where authorized entities add new software versions to the blockchain. This update must go through a census mechanism to ensure they are valid. So now let's move to the third step, which is continuous monitoring. The flow then goes into continuous monitoring. In this step, monitoring nodes are placed throughout the power system network. These nodes periodically check the integrity of the software by comparing the digital signature of the installed software with the one recorded on the blockchain. So now you must be wondering, what is blockchain? So blockchain is a decentralized database in which our data will be stored, which is provided by the government. So now let's move to the fourth part, which is alert and incident responses. If inconsistencies or unauthorized changes are detected during the monitoring, the flow leads to alert and incident response. This step is where the system raises an alert and incident response plans are activated to address any security issues. So then our flow will move to the fifth step, which is new software version and digital signature validation. So in the specific example section, the flow starts with new software version, representing the introduction of a new version of the software. It moves to digital signature validation, which is verification of digital signature of newly deployed software to ensure its integrity. The flow of the program then goes into the sixth step, which is monitoring nodes and code scanning. The flow then goes into monitoring nodes, indicating that these nodes continuously monitor the system. Then it proceeds to code scanning and vulnerability assessment, where periodic code scans are performed to identify and report any known vulnerabilities in the software. These results are recorded on blockchain. Now the program flows into the seventh step, which is threat intel network, access control and audit trail. From code scanning and vulnerability assessment, the flow branches to several key components. Threat intel network represents a network of security experts who share threat intelligence and coordinate response. Access control and governance enforces strict access of control and governance within blockchain network. Immutable audit trail represents the blockchain capability to create a secure and tamper-proof record of all software updates and security events for forensic analysis. Now, coming to the last part, which is the final and the end part of the flowchart. The solution integrates blockchain. Finally, the flowchart ends with an end node. So now coming to the 8th step, which is the end of the program. So finally the flow diagram ends with an end node. The solution integrates blockchain technology to provide a secure and transparent environment for software verification and continuous monitoring. This makes it difficult for attackers to exploit vulnerabilities, including 0 days attack in power system software. The blockchain immutability ensures that all actions and security events are recorded and can be analyzed for forensic purposes. Additionally, collaboration among security experts and strict access control further enhances the security of the system. So this is the overview of our prototype, and now at this note I would like to conclude this video, and I hope you like the idea of ours and you would definitely look after it. Thank you.